Welcome to EDU World Space.
For this problem, we have to analyze a pendulum, which is swinging along a fixed point. We have a theta angle, we have a mass, and we are required at this position where theta is equal to 15 degrees, the mass is equal to 1 kilogram, and the length of the rope of the pendulum is 0.8 meters. This rewrite this 15 degrees. So we need to find where are the acceleration tangential and radial at this point, and we also need to find the tension of the rope. So we can draw our free body diagram to have tension. We have mg, and we will have components, and we can call it mg radial, and we can call it mg tangential for the x and y, equivalent to x and y positions. So we do our summation of forces for radial. We have tension minus mg(r), which must be equal by Newton's second law to the mass acceleration tangential. So we have T minus mgr, and by trigonometry we know that mgr is equal to mg cosine 15 degrees, and mg tangential is equal to mg sine 15 degrees. So we can actually replace mgr by mg cosine 15 is equal to, we know the acceleration is equal to v square r. So this is going to be m v square r. So from this expression we can solve for the tension. So tension is going to be equal to m v square r plus mg cosine 15. Tension, if we substitute the values, we have 1, we have the velocity is also given from the problem, and I think is its velocity at this position is 1.40 meters per second. So we have 1 4 square divided by, this is going to be the radius, is the actually the length of the rope. So we have 0.8 plus mg, which is 1, gravity acceleration 1 cosine 50. If we complete the math, we find that the tension is equal to 11.9 meters. So this is the first part of the problem. Now we can solve for the acceleration, for the radial acceleration. We have forces. We can solve for tangential acceleration equal to mgt, which is also going to be equal to, by Newton's second law, m a t. Actually here I wrote t, but it should be radial, as we are talking about the radial component. Now for this we can say that the mgt is equal to mg sine 15 is equal to m acceleration tangential. So if we solve, we can just cancel out this m, and the acceleration tangential is going to be equal to g due to gravity sine 15. Then the acceleration tangential is equal to 2.53 meter square second. So this is for the tangential acceleration. Finally, we can go back to this equation, and we know that t minus mg cosine 15 is equal to mr ar for the radial acceleration. So now we know the tension, so we can solve for radial acceleration, which is minus 1 gravity cosine 15 and all this divided by m, which is 1. If we solve this, the radial acceleration is going to be 2.42 meter square. And this is the radial acceleration. So we have radial acceleration, tangential acceleration, and we have the tension of the cable. And this is the solution for the problem.